Assalamu alaikum dear students. Today we are going to solve 062542 and this is of May-June 25. Question number 1, figure 1.1 is a speed time graph of an ice scatter. So here you have the speed time graph. Speed is given up to 12 and the time is given again 12 second, 12 meter per second, and on the x-axis you have 12 second. Okay. Describe the motion of the scatter in between time t is equal to 0 to time t is equal to 3 seconds. So where you are, so simply you can say that here we can draw a line, and this line is telling us that this is the time which they are mentioning here, 3 seconds. So what you can say and see, the velocity is a constant velocity. There is no change in the value. So answer is very simple. So what you can write here, constant velocity. Okay. Calculate the distance traveled by the scatter between time t is equal to 0 and time t is equal to 3 seconds. Now in between this time, meaning 0 to 3 seconds, what is the distance covered? Actually here, whenever you will solve these type of questions, you have to remember two things. One is that the gradient of the graph, gradient of VT graph is acceleration, and the area under VT graph is distance or displacement, distance covered. So in this part, when they are saying what is the distance traveled by the scatter between time t is equal to 0 to 3 seconds, so it means that actually you have to determine this area, this whole area, and as you can see that this is a rectangle, so very simply you can calculate the area. What is the area over here? So as I said that the distance traveled, you can write the sort of formula here that distance traveled is equal to area under VT graph, which is nothing but V into T. So what is the value of V over here? You can check, and the value of time you can get from, obviously, from the x-axis. So over here this value is 11, and you already know that here you have t is equal to 3. So 11 multiplied by 3 will give you the answer, which is nothing but 33 meter. So I think it's very simple. But remember one thing, that here they have not mentioned the units. So be careful with your value. You have to write the unit of the distance covered as well. So this is very important, that wherever they are not giving you the units, you have to write the unit. Okay. Now, part C1, state what is meant by deceleration. So it's simply the definition of deceleration. So you can say that this is the rate of decrease of velocity, rate of decrease of velocity. Simple definition of deceleration. Any acceleration is the rate of change of velocity. Any when you are increasing the velocity, you have acceleration, but when the velocity is decreasing, the term is used, the deceleration. Okay. Draw a tangent to the graph at time t is equal to 9 seconds. In part 2, what the question is saying, draw a tangent to the graph at time t is equal to 0 second. Use the tangent to calculate the deceleration of the scatter at 9 second. So as we have already discussed this point, that when you will talk about the velocity time graph, what you will say and what you will do, the gradient or tangent at one point, in this case obviously, as you can see that the gradient is not same throughout, so they have mentioned that what time they want to know the deceleration. So here they are asking for 9 second. So 9 second is here. At this time, what is the deceleration? So what they are asking, first of all, draw a tangent to this line. So what you can do, obviously draw a tangent here. It's very simple. Tangent is a line which is touching your required point or making an angle of 90-degree at this point. So here we are. Okay. So what you can do, you can simply find out the gradient and you can extend it. Here you have this situation that you can find the values of your coordinates, and I have taken over here coordinates which are nothing but 7 from here, and this is something like 2.8. So 7 and 2.8. On the other side, what you have 11.4 and what is the value of the coordinate for y-axis? 0. So simply you can do a very simple calculation, as I said, that the gradient is required. So what you are doing here, A is equal to V minus U divided by T2 minus T1. And basically, again, as I said, that it is nothing but the gradient. M is equal to Y2 minus Y1 divided by X2 minus X1. Over here, you have velocity as the numerator and the time as denominator. So we have taken these values. So what is the value of V? This is simply 0. And what is the value of U? This is 2.8. And as far as the time is concerned, here we have 11.2 and 7. So what you can do, simply calculate this value and you will get the result. So 2.8 divided by 11.2 minus 7, this is nothing but 0.66, or you can write it here 0.66666. So this is 0. I am taking as 0.67. Again, the same thing. Over here, you can say that the result will be negative meter per second square, 0.67. But as far as the deceleration is concerned, the definition of the deceleration we have already written over here, rate of decrease of velocity. So when you are writing A, any acceleration, then the value is in negative. Negative acceleration is nothing but deceleration. So in your answer, you need not to mention negative sign, but obviously the value and the unit. I hope you have understood this point, that the negative sign we will not use when we are going to write the value, because over here they have already mentioned deceleration. What we have used here, the formula is for the acceleration. So be careful of this change. So you need not to write negative sign with this answer over here. Okay. So question 2, figure 2.1 shows a balanced uniform meter ruler made of wood. Here they have given you a ruler made of wood. So meter ruler means 1 meter ruler. The width of the ruler is this much and the thickness of the ruler is this much. So they have given you the width and they have given you the thickness of the ruler. Define the moment. So simply here you have to write the definition of the moment. This is the product of the product of force and the perpendicular. This term is very important. You will not write only distance. You have to write perpendicular distance. Perpendicular distance from a fixed point. What is this fixed point? This is nothing but pivot. So be careful of these words, then you will get 1 mark. If you will write only the product of force and distance, this will not give you any mark because product of force and distance is another term which is work. So be careful. Now part B. On figure 2.1, mark the position of the center of gravity of the meter ruler with a point label X. Label the distance of X from 0 centimeter end of the ruler. So what you have to do? You have to write the point, you have to mention the point, and you must remember that when we are talking about a ruler which is uniform, this is very important term over here, uniform meter ruler. So whenever you have any object which is uniform in shape, its center of gravity will be at the center of the structure. And over here, the if you have 100 centimeters, so somewhere here at 50 mark, you will have 50 centimeter, you will have the center of gravity or center of mass. So what they are saying here, mark the position of the center of gravity of the meter ruler. So where you will mark this over here because this is the center, and 50-50 distance is 50-50 from both sides. So this is very important to remember that whenever you will have the uniform distance, you have to, or uniform meter ruler, then you have to mention this at the center of the ruler. So this is very important. Now in part C1, show that the mass of the meter ruler is this much kg. Mass is this much kg. So what you have to do here, first of all, you must remember that when they are giving you 3 marks for this, can say question, they demand something which is, you can say, not very brief, but you have to apply something which is in detail. So what you can do, what you can say, as far as this weight is concerned, this weight is trying to rotate the body how anti-clockwise or clockwise. So this is anti-clockwise. Be careful. And this weight is trying to rotate the body clockwise. Here you must remember one more thing that as far as the weight of the ruler is concerned, weight of the ruler is also not at the pivot, but it has a distance from the pivot. So what you have to do here, you have to mark this one, and obviously this weight is also acting downward. Before this, actually we have to label the distance of x from 0 centimeter of the ruler as well. So actually we have to mark here a distance as well. This is the part of this thing. the part of this part, question B. So we have to mention this distance as well. Okay. So what actually I was telling you that as far as the anti-clockwise moment is concerned, here we have this value, and be careful that the distance from the pivot, actually the mistake normally you can make is that you are taking this distance. This distance is not required. Actually, this is the distance from the pivot which is required. So, anti-clockwise torque is equal to clockwise torque by the moment. As you have studied in case of the equilibrium, we have this formula. What is the formula? So, simply you can say that here we have anti-clockwise moment is equal to clockwise moment. Anti-clockwise moment is equal to clockwise moment. And what is the formula for moment? So simply you can say that we have already written the definition somewhere. This is the definition: force into perpendicular distance. So be careful of this fact that the force in this case, which is taking the body or rotating the body anti-clockwise, is 0.34 and multiply by. Now, what is the perpendicular distance from the pivot? So here you have the pivot which is 42, and this is the situation, or this is the mark where your weight is hanging. So simply you can say that it is 42 minus 10, yani 32. As far as the clockwise movement is concerned, now you have two, you can say, weights. One weight is the weight of the ruler itself, which actually you have to find out. Here, actually, you need to find out the mass, but here, actually, the force is not mass, the force is weight. So, be careful of this fact. So, what you will do over here, the distance from the pivot 50 to 42 is 8, and the force is weight of the ruler. So, I am writing WR into what is the distance? 8. Actually, as far as the distance unit is concerned, over here you have actually measuring all distances in centimeters. So you need not to mention here, actually you have to just mention the values. So weight of the ruler multiply by 8, and on the other hand, what you have, the other weight is 1.2 Newton, and this is at hanging at 80 centimeter. So 80 minus 42, this will give you the distance. So 80 minus 32, 8, and what you have over here 48. 48, sorry, it is not 32, it is 42 actually. So 42, it means that here you have 38. So what you have over here, 38. So what you can do, simple calculation, and simple calculation is telling you that what you have, just calculate and get the result. What is the result over here? Actually, you are calculating the weight. So be careful. This is not giving you the mass. This is giving you the weight. So I am not calculating over here. I am just writing directly the value, and this is something which is uh, giving you the weight, and here the value of the weight is something like this. Here you have this situation that the weight is how much you will calculate, find out. So 0.34 multiply by 32, this is 10.88. Over here you have 8 WR plus 0.12 multiplied by 38. This is giving you 4.56. So when you will subtract this value 4.56, and over here you have 8 into WR. So 10.88 minus 4.56, this is 6.24. So 8 WR, WR is simply 6.24 divided by how much? 8. So this is the value you are getting, 0.78. But remember this thing, that this is weight and you need to calculate the mass. So how you will calculate the mass? The M is equal to W over G. Actually, you have to recall the equation for weight. This is W is equal to mg. So M is equal to W over G. So 0.78 divided by 9.81 will give you the answer, 9.81, and you are getting over here 0.0795. So this will be approximately equal to 0.081. So this is your answer. Actually, this answer is already given. You have to just prove it. So this is what you have as far as the value is concerned. And this is, as I said, that actually here you have to only show. So you need not to do anything extra. Just show that here you have this situation of the mass. Okay. Then calculate the density of the wood of the meter. So what is the situation of the density? As far as the density is concerned, you know that this is nothing but mass over volume. So mass you have already calculated, 0.081 or 0.0795, so on. And as far as the volume is concerned, so you will use this information, that the width of the ruler is this much and thickness is this much. So when you will multiply these two numbers, you will get the volume. What is the number? 6.0 into 10 raised to power minus 3 and 2.6 into 10 raised to power minus 2. When you will multiply these two numbers, basically one is width, the other one is the thickness. So width into thickness, you can say, will give you the value of the volume. So here I have written this in numbers. So what you are getting, the result is 519, which is approximately 520. Remember this fact, that if the information or data is given in two significant figures, so your answer should be in two significant figure. That's why we have changed this value from 519 to 520. And again, you have to write the unit. So kg per meter cube is the unit. So as you can see that meter is given over here. So this will be the value, and the value is nothing but what you have over here. So this is what we have as far as the uh, your density is concerned. So mass over volume, and you will get the density. Okay. Here, actually, we have to use one more thing. I just forget about it. That here the length is also involved. Any volume is not only width and your thickness, but obviously the length is also important. So you will multiply it by length as well. So what is the length? Is the 1 meter rule. So simply one, yani actually answer will remain the same, but as far as the volume is concerned, be careful. Volume is not only the multiplication of thickness and width, but this is also you can say a length is also involved in this calculation, which is nothing but 1 meter. So 100 centimeter or 1 meter. So this is what we have as far as the final calculation is concerned. Now, go to this part, this question. Question 3, define moment. So again, you can see what is the pattern that in each question, at least one sort of definition you have. So you must remember the definition and you need not to think about it at the examination center, but you have to remember this by heart. And the simple definition of the moment is the product of mass and velocity. So this is simply the definition of the momentum. You can write the product of mass and velocity of a moving body, but this part of this sentence is not very much required of a moving body. Obviously, when you will have velocity, the body will be we can say moving. So you need not to write only if you can if you are writing the product of mass and velocity is okay. Then over here, figure 3.1 shows two toy trains A and B on a track. Here you have train A, here you have train B, and as you can see, they are moving in opposite direction. The mass of train A, the mass of train A is this much kg, so you can write here MA, and the mass of the train B is 0.21 kg, so you can write MB. The trains do not have motors, so they do not have motors. This is another information. So you will see that in number of questions, they will actually give you a sort of story, and then based on that story, they will ask the question. So the part of the story is that the trains do not have motors, so be careful. Train A travels towards train B and they collide. So what they are saying that the train A travel towards B, yani train B is not moving only, train A is moving. Let's see what they are saying. Immediately before the collision, the velocity of train A is this much to the right. Velocity, yani initial velocity of the train A is giving as 0.34 meter per second. Okay. And the velocity of train B, yani the train B is also moving, is not at rest. So the velocity of train B is 0.12 meter per second. They train stick together when they collide. Stick together when they collide. This is very important sentence. It means that after collision, their velocities will be simply the we can say same velocities because now they will move like a single body. Calculate the velocity of the trains immediately after the collision. So what you will write? So simply you will say that we are going to apply the law of conservation of momentum. Law of conservation of momentum says that the total momentum before collision is equal to total momentum total momentum after collision. So what is the total momentum before collision? So simply you can say that the momentum of body A minus momentum of body B. So why you are taking minus? Because the velocity of the train B is towards left. So what actually we are considering? Right is positive, left is negative, And we also know that momentum is a vector quantity. So when you will use the concept of vector, obviously the direction is very important. So it means that the initial momentum of the train A is positive. So the initial momentum of the train will be negative because it is in opposite direction. But total momentum of before the collision will be MAUA minus MBUB. And as far as the total momentum of the system after collision is concerned, so you can say that this is MAV plus MBV. What is V? V is basically the velocity after collision. So simply you can take this velocity as common, and as they are asking, calculate the velocity of the train immediately after the collision. So basically, you are going to calculate the value of V. So what is the mass of A? So this is 0.45. What is the velocity? Initial velocity 0.34. And over here, you have the value of mass of train B, and the velocity before collision is 1.2. As far as the masses are concerned, obviously they are not changing during collision. So simply you can say that 0.45 plus 0.21 will give us the total mass of the system, and we want to calculate V. So when you will calculate V, you will get the answer which is 0.19, or as I said that you can write 0.20 as well. So this is meter per second. And obviously, as far as the direction is concerned, this is towards right because the mass of the train A is greater than mass of train B. So what will happen? The ultimate direction will be towards right. So you can write here the answer in this way, 0.20, and the direction is obviously towards right. So as far as the part C is concerned, a different train is traveling with a momentum of 0.06. Here you have the momentum, not the mass, not the velocity, but the momentum is given. The train slows down and stops after 2.1 seconds, so time is given. A different train is traveling with a momentum. Calculate the average force acting on the train during the time. So remember this fact that as far as the force is concerned, average force is nothing but the rate of change of momentum, rate of change of momentum. So simply you can say that there is a value which is the change in momentum. A different train is traveling with a momentum of this much. The train slows down and stops. When you will say this, the train stops, you will say that momentum, the final momentum is zero. So you can say that this is your initial momentum, and here you have the final momentum. So what is the rate of change of momentum? So PF minus PI divided by time. Yani final momentum minus initial momentum divided by time will give you the rate of change of momentum, which is nothing but force. So what is the situation over here? Zero, as I said that this stops is telling you that momentum, final momentum is zero. As far as the initial momentum is concerned, 0.26, and time is 2.1. So what is the change? So simply you can say that this is the situation over here, negative 0.12 Newton. So this is the average force, negative. Negative means the opposing force. And because of that opposing force, obviously the momentum becomes zero. So here you can write this negative sign as well. Because as I said that the momentum is a vector quantity. I hope up to this stage you have understood what we have discussed. If you are new on this channel, subscribe this channel, like. If you are understanding everything, share with your friends so your friends can also get benefit of this discussion. As far as the you can say theory is concerned, obviously we have been discussing the theory in our theory classes, but over here we are solving 062542 variant of May June 25. Okay, so question number 4. Question number 4 is the question based on the you can say heat part, and this is figure 4.2 shows two metal containers A and B. What containers you have? Container A and container B. As I already have told you that they will first give you a sort of story, and based on that story or information they will ask questions. So here they are giving you the dull black outer surface. Here you have shiny white surface, and the story is that container A has a dull black outer surface and container B has a shiny white outer surface. Uh, A and B both contains very hot water at time t is equal to 0. The temperature of the water in each container is recorded every time. So what they are telling you that in both of the containers you have water, and what water actually here you have the very hot water, so the temperature of the water is obviously very high at time t is equal to 0. And what the students are doing, the temperature of the water in each container is recorded every minute. So after each minute they are you can say measuring the time, and they are measuring the temperature after 1 minute. State which container has the larger temperature change over the first 5 minutes. Explain your answer. So here actually you have to think about it in this way, that a very simple sentence which we have been using. What is the sentence? Good conductor, a good conductor, or you can write in this way, a good emitter is also a good absorber. This is one sentence, and the other sentence is that what you can say, a good emitter is a good absorber, and on the other hand, you can write another thing, that metals are good conductors. So in this case, as both of these containers are made up of metal. So as far as this part is concerned, or this concept is concerned, here we cannot apply, but simply what we can say, that dull black surface is a good absorber, and this is also a good emitter as compared to the shiny surface. So what you will write is state which container has the larger temperature change. So obviously you can say that the container A. And what is the logic? So simple logic. A good absorber is also a good emitter, and dull black is a good emitter. अब ज़ाहिर है कि you need not to write that thus the temperature is changing fast in case of container A. So you need not to write this sentence or this part of the sentence. So this part is enough. After 30 minutes, the temperature of the water in container A remains constant. So what has happened? After 30 minutes, the temperature of the water in container A remains constant. So this is what we have after 30 minutes. Okay. State in terms of energy transfers Why the temperature remain constant? So simply what you will say that the container comes into thermal equilibrium with its outer surface or with its surrounding, not outer surface. So simply one mark question. So what you can write that the container A comes into thermal equilibrium comes into thermal equilibrium with its surrounding. And what do you mean by thermal equilibrium? So this is very important to understand. Thermal equilibrium means that the rate of absorption of the energy is equal to the rate of emission of the energy. So the container A is taking the energy in and giving out as well with the same rate. So you will say that at that stage, the container A has, you can say, thermal equilibrium with its surrounding. So this is something which is important to understand. Then in third part, the experiment is repeated without the lids on the container. So what will happen in this case? State the name of the additional method of energy transfer that occurs. So initially, what was the situation? Only the conduction was taking place. But now, as soon as you will open this lid, what will happen? The convection will also be, you can say, a method through which the energy will lost to the surrounding. Convection. Convection is simply the movement of the energy along with the matter. So this is what we have to understand that as far as the situation is concerned, yani lid is over here, only conduction is taking place. But as soon as you will remove the lid, another method which is the convection will also take place. Okay. Then in part B, figure 4.2 shows a metal pan with a wooden handle. Okay, wooden handle, and what you have as far as the metal pan is concerned is a metal. Okay, explain why there is much greater rate of transfer of energy through the metal than through the wood. So what is the situation? As far as the wood is concerned, it's not a good conductor. So in terms of metals, you can write few words, few lines. And what are these lines? So simply you can say that over here, as I said, that we are talking in terms of metals. Metals are good conductors. First of all, metals are good conductors of heat. Then you know that why they are good conductors? Because metals have free electrons. So write down this fact as well. You know that you have to get 3 marks. So at least 3 points you have to mention. So first of all, metals are good conductors of heat. Then metals have free electrons, not electron only. Free electrons carry energy through metal. So what is happening over here? The free electrons are responsible, you can say. So free electrons are carrying energy through metals. So this is simply the situation. Okay. So that's why obviously there is a great rate of transfer of energy through the metal. Obviously, as we have discussed in terms of metals, so obviously the wood is not behaving in the same way. Here I have actually written these points because I just want to save the time. And question 5 says, part A, describe an experiment to determine the speed of sound in air. State the apparatus used. the measurements taking, and how to calculate the speed of the sound in air from the measurement. You may draw level diagram as the part of your answer. So what we have done here, as I said that I have already written these points to save the time. So what is the method we are using here? We have two sensors, sensor 1 and sensor 2. Here we have a distance between these two, and we are producing a sound by using or hitting the hammer with a block. So what will happen? As soon as the sound waves will reach to sensor 1, the timer which is attached to this whole system will start, digital timer, and when the sound waves will reach to sensor 2, the clock will stop. So in this way we will find out the time which is taken by the sound waves from sensor 1 to sensor 2. This distance is already known. So S is equal to Vt. So V is equal to S over T. This will be our simple formula. So all these points I have written here. Use a setup as above where we have two sound centers, sort of microphones or sensors connected with a digital timer. When we hit the block by a hammer, sound is produced. Timer starts as soon as sound waves reach to sensor 1 and stops when they reach to sensor 2. The time on the sensor is the time of sound waves cover the distance between the sensors. The division of the distance by that time will give you the speed. And I told you that V is equal to S over T. So distance is already known between these two sensors. As soon as the sound will approach the sensor 1, the timer will start. And when the sound will go to sensor 2 or reach 2, the timer will stop. And the time interval will be between the time of these two. And obviously, the distance is already known, so you can find out simply the velocity of this sound. So this is one of the methods. Okay, so 4 marks, very important part. Part B, Bluetooth is used to connect a mobile phone and a cell phone to headphones. State the name of the region of the electromagnetic spectrum used by Bluetooth. Here, actually, they are asking something which is the use of different electromagnetic, you can say rays or waves or spectrum. So here, Bluetooth is using the radio waves. So we are writing here the answer, radio waves. Simple. State the speed of electromagnetic waves. So here you have to remember this fact that as far as the speed of electromagnetic waves in air is concerned, this is always constant, and this is nothing but 3.0 into 10 to the power 8 meter per second for each and every part of the electromagnetic spectrum. Yani whether you are talking about the radio waves or gamma rays or visible radiation and all these, the velocity will remain the same. So simply you can get 1 mark. Now the frequency of the Bluetooth network is this much gigahertz. So as far as the frequency is concerned, they have given you this value. Calculate the wavelength of the waves used in Bluetooth network. So as far as the wavelength is concerned, you have to recall the formula V is equal to F lambda, where lambda is wavelength, frequency is F, V is the velocity. I just told you that whatever the part of the electromagnetic spectrum you are talking about, the velocity is same, and this is nothing but 3 into 10 to the power 8. So this is the velocity. Frequency is 2 gigahertz. So remember this thing that giga is nothing but 1 gigahertz is equal to 10 to the power 9 hertz. And you can remember in this way that giga, you can remember in this way gun, giga is 10 to the power 9 and 10 to the power minus 9 nano. Okay, so you can remember this conversion in this way. Okay, so 2.48 into 10 to the power 9 multiply by lambda as you have to calculate lambda. So the answer is simply coming as 1.2 meter. So here you can write 1.2 meter. That's it. So remember this point that here why they are giving you 3 marks, because 1 mark will be of this equation. The second mark will be the mark for this conversion of gigahertz into hertz, and obviously then the calculation, and you will get the answer. So all these steps will give you 3 marks. So be careful. Okay. So now we have question number 6. Figure 6.1 is a full-size diagram of a lens and an image eye of an object. So here they are starting from the image, not from the object. So full-size image is given over here on the left side. The focal length of the lens is 3 centimeter. So if you will consider somewhere here, 3 centimeter you have, and this distance obviously will be the 3 centimeter. So the other side the same distance, and you will have the principal focus on the other side as well. So now what they are saying in part 1, on figure 6.1 mark 2 points with the labels F to show the positions of the principal focuses, focal points of the lens, which I have actually already marked over here. And then you have the second part on figure 6.1, draw two rays from the image to locate the object. Draw the object and label it O. So now what we have to do, we have to consider two rays, two basic rays you can say. One, or the first we can say the ray which comes parallel to the principal axis, and after passes through the lens it will pass through the principal focus of the other side. So this is your first way which you actually will use to draw the object over here. And the second ray is the ray which will pass through the center of the lens, and without bending it will go straight through the lens. So now what you have, this is the position where you will have your object. As I said that in this case they actually have started the other way around situation. And normally you will see that they will give you the object and they ask you to draw the image, but in this case they have given you the image and they are asking to draw the object. So the object is over here and you will get 3 marks. So be careful. What you have to do, you have to draw these rays and obviously the position of the image and then the inverted arrow you are using for the object. Part 3 of this question, the object is moved so that it is 6 centimeter to the left of the lens. Yani, now they are saying that if you have the situation that instead of this position for the image, nearly this position of the image, here you have the object, then what will happen? State one characteristic of the image formed when the object is in this position. So as you can see here that the image is upright, so the image is upside down, inverted, but in both the cases the situation will be the image is always real. But obviously in this case what will happen when you will bring your object on the left side, there is somewhere here, the image will be formed in this position, and what you will say that the characteristic of this is simply you can write it's real, even you can write it's inverted. So this is how you can get 1 mark. And if you want to write only one characteristic, so it's enough to write the real or it's inverted. So either of these two you can write. Okay. Then over here you have B. Figure 6.2 shows a simplified diagram of an eye with rays from a near object. The eye needs correction for the long-sightedness. So first of all, you should know that what is the problem of long-sightedness. You can see the object at a long distance, but you cannot see clearly the object which is close to the eye. So what they are asking here on figure 6.2, draw the path of the rays inside the eyes to show the effect of the long-sightedness. So basically, you know that in case of long-sightedness, your lens, you can say, is not focusing the image at the retina, but after passing through the lens, what is happening? The rays are converging somewhere beyond the retina. So you have to draw something like this, and these rays are converging beyond the antenna, so some retina. So this is what we have here. Okay, so this is the situation of the long-sightedness. A lens is used to correct the long-sightedness. Draw a lens suitable for this correction. Over here, what you have to do on figure 6.2, draw the path of the rays inside the eyes to show the effect of the long-sightedness. So what is the effect of the long-sightedness? That the image is not at the retina, but it is beyond the retina. So this is what we have as far as the this part is concerned. Now what they are saying, a lens is used to correct the long-sightedness. So what actually you have to do, you have to make this lens more converging. So what is the converging lens? So simply you can say there is the convex lens. So this is what we have. Draw a lens suitable for correction. So this is what you have over here, which is basically the converging lens, the convex lens. Done. So this is what you have for question number 6. Now as far as the question number 7 is concerned, you can see there are a number of explanations and definition. State what is meant by an electric field. So what is an electric field? So simply you can say the region or space around a charged body or around a charge or a charged body in which another charge in which another charge experiences an electric force. This electric force, may be the repulsive force or the attractive force depending on the type of charges, like charges repel, unlike charges attract. So we need not to go into that detail for the time being. Only one thing we have to write, that what is the definition of the electric field. That's it. Now as far as this part B is concerned, what they are asking, a plastic rod is rubbed with a cloth. The plastic rod becomes negatively charged and the cloth becomes positively charged. So what is happening in this case? You know that whenever a body becomes negatively charged, it means that the body will gain electron, and obviously the body which lost electron will be the positively charged body ultimately. So what you can write here, explain why. They are saying explain why. The plastic rod is rubbed with the cloth. The plastic rod becomes negatively charged. So what is happening actually over here? So simply you can say due to the friction, due to the friction, electrons transferred from the cloth to the plastic rod. And simply you can say that the plastic rod will gain electron, so it will be negatively charged body or negatively charged rod. So here actually you have to mention the friction and the electron transfer. So this is very important. In the second part of this question, part B2, the negatively charged plastic rod is suspended by an insulating thread. Yani you have something like this. The negatively charged rod is hanging with a thread, and then what's next? Another negatively charged plastic rod is brought close to the suspended rod. So what you are doing, you are bringing another negatively charged rod close to the first one, and now you know what will happen. So simple thing is that like charges repel each other. State what happens to this suspended plastic rod. So simply what you will say that the plastic rod experiences a force of repulsion. They are like charges. So simply you can say that the suspended rod experience experiences a force of repulsion, a force of repulsion, and moves away. That's it. Now, in part C, what you have defined in part 1, C part 1, define the kilowatt hour. So basically, kilowatt hour is nothing but the unit of energy. And how much energy? So you can say that we have studied V is equal to W over Q, or energy per unit charge. So if you will take E, the energy thing, what you will get? QV. So if you have a charge of 1 coulomb, you can say, and obviously here you have this equation kilowatt n R. So what is the charge and what is the potential? So this is important. This is one thing. And what is happening in this case? This another concept, and the concept is of the power, because here we are talking about the kilowatt hour. So power is nothing but energy per unit time. So energy is nothing but power into time. So when you will take the unit of power as kilowatt and the time is 1 hour, so you are basically talking about the energy which you will have or which you will spend in this way, that the power is of 1 kilowatt and you have been using this power up to 1 hour. So simply the definition you will write in this way, that the energy transferred in 1 hour in 1 hour at the rate of 1 kilowatt. Yani basically this is nothing but the power. So if you have a power of 1 kilowatt and the energy is being transferred for 1 hour, the energy will be 1 kilowatt hour. So this is what we have as far as the definition of the kilowatt hour is concerned. Then you have part 2. A small lamp illuminates an electric oven. The lamp has an output power of 25 watt output power. So you can write here power out, and operates for 220 minutes, 220 hours. So this is the time in 1 year. The potential difference across the lamp is 230 volt. So this is V. Calculate the energy transferred by the lamp in 1 year. Remember this thing that the 1 year is not the total time. Time is only 220 hours. So be careful of this fact. And what they are saying, calculate the energy transferred by the lamp in 1 year, give your answer in kilowatt hour. So simply what you will say that energy is nothing but power into time. So what is the power? 25. What is the time? So time is 220 hours. 220 hours. But what actually you have to do? One thing which is very important, that if you want to convert the unit, you have to change this watt into kilowatt. So how you will do this? So simply you can say that this will be divided by 1000. So when you will use this concept of kilowatt with time, 220 hours, so what you will get? So 25 divided by 1000 multiply by 220 will give you 5.5. So this will be the energy in kilowatt hour. The unit is already written here, so only the magnitude you have to mention. This is nothing but the 5.5. Value is 5.5. In the next part, calculate the current in the lamp. So you know that P is equal to IV, power is equal to IV, and what you have here, as far as the power is concerned, it is 25 this time. Current you need to calculate, and the potential or voltage given is 230. So it's very simple. Put the value, get the answer situation. 25 divided by 230, which is coming as 0.108, or you can take it as 0.11. So this is 11 ampere. Be careful that in this case they have given you the kilowatt hour and unit of the energy, but here they have not. So here you have to write what is the unit of the current. Remember this thing that only the magnitude is not enough. Always you have to write the unit if it's not given. So in this case, the ampere is obviously the unit which is not given, so you have to write it. Okay. So this was your question number 7. Come to the next question, question number 8. What is the question here? In part A, they are telling you that figure 8.1 shows simplified diagram of an AC generator. Okay, you have studied AC generator, and you know that this is a very sort of common sort of question, frequently asked question, you can say. And what they are asking, so very simply, here you have the first part, state the name of the components P and Q. So P and Q, are nothing but slip rings. So just write it here, slip rings. And the X and Y, what is X and Y? So you know that X and Y is nothing but carbon brushes. Carbon brushes. Okay, carbon brushes. Explain why an electromotive force is only induced when the coil is turning. So you know that the electromagnetic induction, in electromagnetic induction, you have studied when you have a changing magnetic field linked with the coil, you can induce an EMF in that coil, or electromotive force will be induced in the coil when there will be a changing magnetic field linked with the coil. So simply you can say that a changing magnetic field, a changing magnetic field is linked with the coil. That's it. And in the next part, state one possible change that causes a larger EMF induced. So you have studied this fact as well, that if you increase the strength of the magnetic field, if you will increase the rotation, so all these facts, if even if you will increase the number of turns of the coil, so all these facts or all these factors you have. In this case, you can write any one of these three or four possibilities. So the one possibility is simply you can write here, use the stronger magnetic field. Then they are asking what is the effect. So possible change is the stronger magnetic field you are using here. Or even you can write use a stronger magnetic field. That's it. Simple. In part B, you have a question based on electricity, and you can see that they have given here you a simple circuit, which is basically the parallel circuit. If you can recall that here you have a source, and all these resistors are parallelly connected, and both of these terminals are of negative and positive. All the right hand side connected with positive, all the left hand side connected to the negative. So basically you are talking about the parallel combination of the circuit, and obviously here the voltmeter is also given, which will or which can measure the potential difference across all these individuals. But here obviously B and C are in series, so the overall potential difference between B and C will be measured by the voltmeter. What they are saying now, the resistors A, B, C, D are identical, meaning they have the same value. The current in the resistor A is 2.4. So what they are telling you that in this case the current is 2.4 ampere. 2.4 ampere. Okay. So this is very important. And next thing is that state the value of the current in the resistor B. Explain your answer. So remember one thing, that you need not to calculate any, you can say current, but only one concept you will use here. What is the concept? You will say that as far as A and B and C are concerned, B and C are identical to A. It means that the overall resistance of B and C is double of the resistance of the resistor A. So it means that the current will be half. Why? Because we know that V is equal to IR, where I and R are related inversely. V is constant. So you know that all these resistors are connected with the same battery, same cell. So it means that if you have a current of over here you have current of say 2.4 for resistance R. So if the resistance will be double, because here you have B and C, and you know that when the resistors are in series you have to add their resistances. So 2R means actually what you have to do, you have to take half of the current, and the current will decrease by half if the resistance will increase to double of its initial value. So simply what you will write, that the current value is, you actually, as I said, that you need not to calculate anything, but here you have to write directly that is nothing but 1.2 ampere. And what is the logic? What is the explanation? So simply you can say that the resistance total resistance of resistor resistors B and C is twice 2 times of resistor A, thus current is half, or current in it is half. You can also mention that I is inversely proportional to R. Calculate the value of the current. So what is the value of the current? Again the same thing. The current I is coming towards this terminal, say A, and it will divide. So you can say that it is IA. Then a part of the current is going towards resistor A, and the rest is moving towards BC. Then what is happening at this junction, say B, a part will go to the branch B and C, and the rest will go towards D. So it means that, again, the same logic you can use, that here you have the current of 2.4 ampere. So the same value of current you will have in D. So simply you can say that, as we have just discussed, that the current in B and C is 1.2. So what will be the total current? It's very simple. Total current will be simply equal to IA plus IB plus C plus ID. So what is the value of the current which is flowing towards A is 2.4. Over here, the total current is 1.2, and then again it is 2.4. So add all these and you will get value as 6. So what is the value? 6. And what is the unit? Ampere. So the answer you have to write is 6 ampere. Again and again, I'm telling you that the units are very important. Where they have given you is fine, but if you do not have the unit in your answer, so you have to write the unit. Be careful. The reading on the voltmeter is 5. The rating in voltmeter is 5. Calculate the resistor A. So you know that if you want to calculate resistor A, you can write RA. So V divided by I, and this will give you the result as far as the resistance is concerned. They have given you the potential as 5, and what is the current you have calculated already in your resistor A is 2 point. Actually, it's not calculated, it's only given over here. So you need not to calculate anything, but obviously you have to calculate R, which is 2.08, or in two significant figure, you can say it is 2.1 ohm. So 2.1 ohm is the result. Okay. So this is what you have as far as the question number 8 is concerned. And let's move to question number 9. In question number 9, you can see that basically this question is of the radioactivity, and A1 state what is meant by the background radiation. So you know that background radiation is the radiation which is already or always present in the environment. So same is the answer you can write. And what is the definition you can say? That this is simply the radiation always present, radiation always present in the environment or surrounding, you can say, of a particular source. So this is what you have as far as the simple answer is concerned. Radiation always present in the environment, we will consider as the background radiation, which will always be, you can say, the extra, you can say, the reading as far as the measurement is concerned. State one source that makes the next part a significant contribution to the background radiation. So there are a number of possibilities. You have concrete around, and you have different sort of radioactive materials around, but I am writing only one over here, and this is the cosmic rays. Cosmic rays. State one source. So I'm writing only one you can say answer, and this is the cosmic rays coming from the sun. Then part B, radioactive isotopes are used in some medical treatments. Okay, you have already studied this, that you can use the radioactive isotopes in medical treatments. They are telling you that the radium 23 is an isotope of radium. Okay, radium 223 decays by the emission of alpha particles to an isotope of radon. So you can have here one information that the alpha particles are being emitted and the radium is changed into radon, and they have given you a simple equation here. The you can say radiation is alpha particle, you can say, or alpha radiations, and they are saying complete the nuclide equation. You have to remember this is nothing but the nucleon number A, and this is the proton number. So as far as the alpha particles are concerned, you know that they are nothing but the nucleus of the helium, and so we are writing here their A, and here you can say P, the proton number, which is 4 and 2. And simply when you are getting radon, so the atomic mass or nucleon number of radon will be 223 minus 4, which is nothing but 219. And on the other hand, as far as the proton number is concerned, so here you can write 88 minus 2, which is nothing but 86. So when you will write these two figures, you will get 2 marks. Radium 23 is injected into the body to treat a specific organ. In part 2, they are saying radium 23 is injected into the body to treat a specific organ. Explain why the source must be inside the body. Yani, what is happening? Obviously, you need to use alpha particle over here, and you know that alpha particles are not very penetrating particles. So, what will be the situation, or why the source must be inside the body? So, you can say that the if the body will be if the alpha particle will be outside, obviously they cannot penetrate into the skin. So, simply I am writing here that alpha particles would be absorbed by the skin as their penetration is very small. Only one mark you have, so it's enough to write this line. Then in part C, an isotope of actinium is injected into the body to detect cancer in one of the organs. Okay, what is happening? Actinium is the isotope which you are using here to detect the cancer, and you are injected into the body. The half-life of this isotope is 6 hours and it decays by emitting gamma radiations. So half-life is a short half-life, and the emission is of gamma radiation, which is dangerous, you can say, most penetrating. The radiation is detected outside the body. And what is happening? Obviously, as I said, that you have a very uh, penetrating radiations, gamma radiations. So what is happening in this case? The radiations is detected outside the body. Explain why a source of gamma radiation is used. So simply you can say the same thing as I said, because you are detecting the radiation outside the body, so you should have to use the most penetrating, you can say, radiations. The gamma radiation pass out of the body to detect. So simply you can write this line that gamma radiations, gamma radiation pass out of the body to the detector, because the detector is outside the body. So if you will use anything else, so obviously you cannot get it outside the you can say body. You cannot detect it because the penetration of beta particle and alpha particle is less, very small. And then they are saying explain why a source with a short half-life must be used. So you know that if you have the long half-life, it means that for a long period of time you will expose the patient to the radiation. So why we are using the short half-life material over here? So simply you can say that a few days, after a few days, little radiation is emitted. Any simple thing is that your patient is not exposed for a long time. So here you have only one mark, so you can write only this thing, that after a few days, little radiation is emitted, and obviously you can write in this way that to save the patient from a longer exposure to the radiation as well. So the same sentence, or not same sentence, but same meaning of the sentences you can say. So I have written in this way. I hope it's clear, and this is question number 9. So now we are going to the, I think it's the last question, question number 10, the last question, okay. So what they are asking here, you know that is this question is based on your space physics thing. Here, table 10.1 shows the data of for planets A, B, C, D. So here you have planets A, B, C, D. Here you have the surface temperature. Here they have given you the diameter in kilometers, and then you have the gravitational field strength. So this is the data you have for different planets A, B, C, D. State and explain which one of these planets is closest to the sun. So simply what you will say, you have to check that what is the situation of the temperature. So here 623 is the highest temperature, which is nothing but of the planet B. So simply you can say that which planet is the closest. So planet B is the closest to the sun. And why? Because we are writing this reason with the highest with the highest surface temperature. So they are asking for the reason. So you have written this reason over here, that explain. So what is the explanation? Simple explanation is that closer to the sun, more will be the surface temperature. And as you can see that 623 is the surface temperature of B. So you can say that this is the closest to the sun. Calculate the surface temperature of planet D in centigrade. So what they have given you, they have given you all the temperatures in Kelvin degree. So what they're asking here, calculate the surface temperature of planet D in centigrade. And you know that the simple formula, the temperature in Kelvin is equal to 273 plus centigrade. So what is the value they have given you? 93 Kelvin, 273 plus centigrade. So in centigrade, what you will have? Minus 180. Minus 180. Here you can see that they have given you the centigrade thing already. So you have to write only the value which is minus 180. That's it. Then what they are saying, an object falls through a height of 2 meter on each of the planets in table 10.1, this part. An object falls through a height of 2 meter from each of the planet in 10.1. State and explain on which planet the object falls 2 meter in the shortest time. Ignore any effect due to the atmosphere. So simply you can say that here we have to think about the gravitational field strength. So gravitational field strength of which planet is the greatest? So the value is 23, which is of the planet A. So simply you will write in this way that if you will consider like potential energy, then what is the potential energy? mgh. And you know that they are asking explain which planet of the object is the shortest time, fall in the shortest time. So obviously when you will have the greatest value of g, then what will happen, the highest velocity you will have. And when you will have the highest velocity, and basically the potential energy or gravitational potential energy is changing into kinetic energy. So what is happening in this case, as they have already mentioned here, ignore any effect due to the atmosphere. So it means that the total loss of potential energy will come as the gain in kinetic energy. So the highest velocity will based on the value of g, because all of them are falling from the same height. So velocity is depending only on g. So higher value of g, greatest value or higher value of velocity, so the lesser time will you can say be taken by the object. So these are few things you can write here as the planet A has the greatest value of g, gravitational field strength, thus the maximum downward acceleration, meaning velocity change will be the highest and downward acceleration will be the maximum downward acceleration. So it means that what is happening, shortest time. So we need not to shortest time, it's already we can say mention here, and obviously you are talking about the same thing. So you need not to write the shortest time thing. So this is what you have as far as the part 3 is concerned. Now in part B, what they are asking, in part B of this question, 10.1 shows some of the stages in the life cycle of the massive star. So as far as the massive star is concerned, they have given here the life cycle. You can say massive star expands, and you know that when massive star expands, they form red supernova. Red supernova. Then next stage is supernova. They have already given you. The next stage after supernova, you will have the situation of the nebula, which contains what? Which contains hydrogen and obviously some dust as well. And the next point, it leaves behind. What is happening? What they are giving you? So they are giving you here the black hole or the neutron star. You know that what is black hole? The black hole is something dead, you can say star, and it will have, or the black holes have greatest attraction, even they can absorb the light. So the gravitational field strength is the highest as far as the black hole is concerned. Complete figure 10.1 by adding correct terms. We have already done this. In part 2, state the quantity that the brightness of the supernova in a galaxy can be used to determine. So, what quantity you can determine by the brightness of the supernova? So, you know that you can determine the distance from the Earth to the galaxy. So, this is something which is important to know, that as far as the distance is concerned, distance of the galaxy from the Earth. So, distance from the Earth to a galaxy. This is what you can measure or determine when you are considering the brightness of the supernova. Okay, so that's it. This is your paper, and we have solved all these questions, Alhamdulillah. And remember one thing, I have actually solved all four ones from 2020 to 2025. But when I solved 2020 to 2025 papers of 4-1, I have taken this as the topical, yani all the topics of say from 2020 to 2025, I have solved in one discussion, like heat or mechanics and electricity and all these. Now I am solving full papers of 4-2. So this is another series, you can say, where I am solving these papers. I will solve inshallah 4-2 of 24, and obviously your ATP paper as well. So if you are getting a good concept and understanding what is happening here, what is the discussion here, so like this video, and if you are not a subscriber, subscribe this channel, and I think this will be a good source for you to understand physics and physics concept, and share with your friends so they can also get benefit of this or advantage of this discussion and the lectures. I have lectures, and I have you can say all these solutions, so you can get a good benefit of it. So good luck for your exam. See you. Allah Hafiz. Take care.